Lesson 11.9 is about the normal distribution. By the end of this lesson, you should be able to draw a normal distribution and label the probabilities on that distribution. To begin, we need to talk about variables. There are two types of variables, the discrete and the continuous variable. The discrete variable is a variable that takes on specific values. For example, if you flipped a coin 10 times, you could ask how many times would we get 3 heads, and you get a specific value. If you flip a coin 10 times, you can only get heads a certain number of times. You can't get like 3.5 heads or 3.6 heads on flipping a coin. So that's a discrete variable. Another example of discrete variables is when you're counting people. People come in whole numbers. You can't have a half a person. So that's a discrete variable. Continuous variables, on the other hand, are variables that can take on an infinite number of possibilities between two endpoints. For example, if you were to measure the length of your pencil could be 5 inches long, or it might be 5.1, or it might be 5.11. It has an infinite number of possibilities between 0 and, say, 6 inches long. That makes it a continuous variable. So when we're talking about the normal distribution, we're talking about continuous variables. When we were talking about the binomial distribution, that related to discrete variables. So the normal distribution would look something like this. You have a number line, like so, and then you have a curve that's highest in the middle, and it flattens out on each side. Roughly like that. That's what a normal distribution looks like. Within the normal distribution are some specific things that you need to know. First of all, in the middle is the mean. Measure of central tendency would be the mean. Coming out to the right from the mean, we have 3 important points. This would be the mean plus 1 standard deviation, the mean plus 2 standard deviations, and clear out on the end you have the mean plus 3 standard deviations. And we would have the same thing going the other way, only it's minus on the standard deviations. Then inside of this picture we have different probabilities. The curve here represents all possibilities, and the area under the curve represents probabilities. So in this section right here, approximately 34% of all of our observations should land in this region, which is why that's the tallest part of the chart. 1 standard deviation further to the right, we should get about 0.135, or 13.5% of our observations. And in this small region here in the tail, we should get 0.0235. And way down here at the very bottom, there's very little left, 0.0015. And it goes the same on the other side. If you add up all these probabilities, it equals 100%. So if the distribution is not normal, it could be skewed. So if we had a distribution that was, instead of having the tallest part in the middle, it was tall on one side and then tailed off to the other side, this would be a skewed distribution. We could also have a distribution that's skewed towards the other side, like so. This one on the left is called skewed right, because the skewness is determined by the tail. Since the tail is longer on the right, this is skewed right. When a distribution is skewed right, it means that the mean will be pulled to the right. Of the median. That's what it means to be skewed right. So this other distribution is skewed left. So that means that the mean is to the left of the median. So here's an example involving brown bears. This bar graph gives the weights of a population of female brown bears. The red curve shows how the weights are approximately normally distributed around the mean, and the mean is 115 kilograms. Approximately what percent of female brown bears weigh between 100 and 129 kilograms? So here's 100. Here's 129. So we're going to add up all of these probabilities that are in the graph. So this first one appears to be about 24%. And the top one here looks like about 43%. And then this last one looks like it's also 24%. So approximately 91% of brown bears weigh between 100 and 129 kilograms. Okay, this will be continued on the next video.